Hey guys, welcome back to the channel. My name's Chen. Today we're going to do a teardown of the foot pedal, see how it works, and also see if this is a project that we can complete to convert it from the foot pedal to a wired control. In my research, I found a schematic of the foot pedal. I'll post this in the description, a link to it, so you guys can review it. Let's go ahead and tear down the foot pedal. On the foot pedal we have, looks like 4 screws underneath. Let's do this real quick. Oh, 3 screws. And we have the foot pedal here. Doesn't look like anything too complicated. It has a control board, switch, and then I'm going to keep the foot control, the left and right control intact. I don't want to take this one apart. This is my spare foot pedal. I have another one here, so we can take this one apart. I can show you what it looks like with everything removed. This piece is screwed in still, but basically this is it. So we have our left and right, which actuate this piece here. So if you go right, it shifts this piece this way, and it ends up pushing these little pins here, 1 and 3, and then right pushes 2 and 4. We'll probably use that a little bit later, but I just want to show that to you now. So yeah, I mean, this is pretty simple. Let's examine the circuit board a little bit more and see what we can learn. All right, so we can look at the circuit board. We have that here. Sorry, this one is a little damaged. I guess it goes in this way. It's a little damaged. When I took it apart, I was trying to unsolder the wires, but it has this hard glue on top, and when I heated it up, the protective film on top got damaged, and I just had to peel it apart. So this circuit board is probably still okay to use. I could probably repair it if I really wanted to, but I'm not too worried about it. In my research, I did find a diagram. I'll post it in the video so you guys can pause it and look at it if you want. I'll also post a link to it, and you can download it and review it. It also gives me the pin layouts and wiring colors. So pin E, which is our black wire, is our ground. Pin C is brown, our speed control. A is red, it's a 12 volt signal. B is orange, switch 3.9 volts. F is yellow, it's for our steering motor. G is green, steering motor as well, that's left and right. And then D is a white wire, which is our on and off to the main motor. It also says the test procedure for the foot pedal circuit board is performed with your VOM set on the resistance by 1 scale. The function specifications are as follows, and it gives you these different tests that we can do, and we'll go ahead and do them. I have my voltmeter here. I have it set to low resistance or the shorting function. So it should beep if there's a short. So in here it says actuate S1. My voltmeter should short from pin A to G. So that's the right. I'm pressing on the right pedal and it's shorting out. So we're good there. Number 2 is S2. Should short from pin A to F. My diagram's cut off here on the printout, so F is this one here, and that should be the other direction most likely. Yep, left. All right. And then S3 is pin E to F. So F is this one, E is this one. I believe that is also a left to right function. S3, yep, that one's right. And then E to G, so E to G should be left. Yep. Can't get a good connection in there. I have to press the pedal pretty hard. Looks like the button might be damaged in there. I'll probably have to go in there and clean it up for later use. So we're good there. So that was number 4. S5 is the foot pedal, or the propel pedal. So we want to see a short between D and E. D and E. Yep. And then one more. So with the speed selector off, it says resistance across pin B and E. Okay, B and E is this one. Should be between 550 to 1,000. So let me change my ohms here. So here's I have my pin here, and it's showing about 792 ohms. And then as I change the slider here, it should change my resistance, because this slider is basically a potentiometer, and it changes based off of your sliding. So this is a sliding potentiometer, and so it should change. It should change between. Let's see, there's another one across B and C. So when B and C is the other pin, like the brown wire. Okay. So when I took it apart, I had some issues with the slider, but I screwed it down a little bit tighter, and looks like we're good now. All right, so let's go back to number 7. So with the speed selector off, pin B to E should be between 550 to 1,000 ohms. So it looks like we're at about 800 ohms at 0. One says as we actuate it, the resistance should change, giving you less resistance, since this is a potentiometer and slash like voltage divider. So as we go up in speed, our resistance should go down. Yep, and we're getting about 37 ohms, which in this sheet it should be less than 25, but I don't know how calibrated my meter is. Okay, so that's what I learned from this sheet. Basically how the pinouts work. The pinouts work on this, what the wires do, and next I will I'll go out to the boat, plug it in, and just confirm the red wire and the orange wire are 12 volts and 3.9 volts. All right guys, we're in the garage now. I'm gonna hook up the cable. I cut the wires from the circuit board, and I'm just gonna do some measurements here. Basically I wanna see the red wire being 12 volts, and let's see, the orange wire being 3.9 volts. We're on the boat. It's hooked up. The cable's hooked up. I put it on this wire terminal to help me, I guess, wire up some stuff in the future. So here we go. This is the 24 volt system, 2 batteries wired in series. I have my breaker, so I'm gonna turn it on by just switching on the breaker. All right. So in order for this to work, I have a jumper to turn on the motor, which was the black and white wire. I don't know if you'll hear the relay click in the control board, but I'm going to go ahead and turn on the motor right now so I can do my measurements. I don't know if you can hear that. All right, so I will keep the motor on. So the motor is on now. And I could do my measurements here. I don't know if you can see that. I'll first the 12 volt. Red wire is this one. Change my meter to read. It's about, it's about 12 volts, as you can see. And we're on the ground and the red wire. Next, let's go ahead and do ground to orange, which is speed control. And we have about 4 volts. So close to that 3.9 volts that the service manual tells me. So now we can go back inside, I'll model it, see how things work, and put it in a circuit diagram. Thanks, see you guys inside. We're back inside now on my PC. Just wanted to show you the control board before it was damaged. Go through the service manual real quick, and again, just go through it real quick. We have S1, S2, S3, S4. This has to do with your steering. Here is S5, which I believe is the foot pedal for turning on the motor. And then, let's get rid of that. And then we have S6, which is your on and off switch, permanent on, permanent off. And then, of course, sliding potentiometers right there. And then our control wires. After following the traces on the circuit board, I went ahead and just made some notes. Drew the diagram. We have our sliding potentiometer here, orange wire, brown wire, our incoming 12 volt, which is for our steering. I think we can, the left and right can be controlled by a DP/DT switch, which is double pull, double throw switch. And then the power on, which is this white wire and ground, we can just use a single pull, single throw switch. I went ahead and drew that again. So again, this is a little bit off. We don't want this, we want a momentary switch here. So when nothing's pressed, the whole circuit's open. And then when left and right is switched, then it would actuate into these contacts. The red would go into your 12 volt would say, okay, let's turn left or right by connecting yellow. And then the green would go to ground, and then vice versa. Green would go to the 12 volt, and then yellow would go to ground if you're going in the other direction. The way I looked at it after kind of doing an analysis of this is that I can break this up into 3 different circuits. We have our speed control, which is up here in this box here to the ground. Then we have our steering, which is this circuit here, and then we just have our on and off, which is this circuit at the bottom. So again, let me redraw that for you. So we have our speed control in this section here. Our orange wires are 3.9 volts, potentiometer, and then it goes to, one leg goes to ground, one leg is for the orange 3.9 volts, and then our wiper is our brown brown wire, which is the control wire back to our control board on the control board to say, hey, you know, we need to speed up, slow down. Next, we have the steering control, which I put up here. Again, kind of what I was saying before, we'll use a DP/DT switch. Again, this drawing is a little bit off. When we're not turning left or right, this will be fully open. We go left, then we'll connect yellow to the 12 volt and the green to the ground, and then vice versa. If we're turning right, then we'll have the green at 12 volts and the yellow at ground. And then lastly, we'll talk about the power on and off. Another simple circuit. We have our white 24 volts coming in, and we go through a single pole, single throw switch here, and to ground, which basically says, hey, let's turn on the motor. And then, then it'll do, it kind of works in conjunction with the speed control. There's two motors on the trolley motor. You have the main motor for propulsion, and then you have a motor for turning left and right. We learned a lot today. Surprisingly, after we took this thing apart and looked at the circuit board, everything is pretty simplistic. A lot more simple than I thought it was going to be. We can break the circuit board into three different functions. We can do the on and off, the left and right, and then the speed control. So we went over that. I think it's all kind of basic parts. It's all analog. We'll be able to substitute a lot of this stuff and at least make a handheld mechanical version pretty easily. Some other things that we learned today is that there's two motors, one for propulsion, another one for steering left and right. For speed control, we had the sliding potentiometer. I'm gonna have to do some shopping, do a little bit more research. So in the next episode, we're going to look at the parts that we're going to need. We're going to replace the potentiometer. We'll probably look at a rotary one there. We'll have to look at the on and off switch. I think I already figured that out with the single pole, single throw switch. And then for steering, we have the double pole, double throw monetary switch. Thanks again for watching. Hope this interests you, and I'll see you guys next time. Thanks.